Section 2.1, Frequency Distributions for Organizing and Summarizing Data. When working with large data sets, a frequency distribution or frequency table is often helpful in organizing and summarizing data. A frequency distribution helps us understand the nature of the distribution of a data set. A frequency distribution shows how the data are partitioned among several categories or classes by listing the categories along with the number or frequency of data values in each of them. Some definitions. The lower class limit are the smallest numbers that can belong to each of the different classes. The upper class limit is the largest number that can belong to each of the different classes. The class boundaries are the numbers used to separate the classes, but without the gaps created by the class limits. Class midpoints are the values in the middle of each class, and it's found by adding the lower class limit to the upper class limit and dividing the sum by 2. The class width is the difference between two consecutive lower class limits or the difference between two consecutive upper class limits. Let's take a look at an example. So this has McDonald's lunch service times are shown in the table, and the frequency distribution of the data is shown in the second table. And we notice in the frequency distribution that 11 cars going through the drive-thru took between 75 and 124 seconds, 24 were between 125 and 174, and so forth. How many classes are in the table? We see there's 5 classes in the table. What is the class width? So remember, we take the difference between one midpoint of the first class. So for the first class, to find the midpoint, we're going to add 75 plus 124 and divide by 2, and we get 99.5 seconds. Which class has the highest frequency? And this is called the modal class. And in this case, it's going to be the class 125 to 174. And again, we call that the modal class, the class with the highest frequency. Relative frequency distribution or percent distribution is similar to the frequency distribution, but it shows the percents or proportions in each of the classes. And there's the formulas that we use to calculate those. And the sum of the percentages in a relative frequency distribution must be very close to 100. They might be off a little bit because of rounding, but they should be pretty close, somewhere between 99 and 101%. A cumulative frequency distribution shows the frequency for each class and the sum of the frequencies of the classes below it. So if we go back to the McDonald's lunchtime service times, we see that the cumulative frequency for the second class is the frequency of 11 in the first class plus the frequency that was in the second class. We add those together, that was 24, and we get 35, and so forth. In statistics, we are often interested in determining whether data have a normal distribution, and we'll revisit this frequently during this semester. Here's some characteristics. The frequencies start low, then increase to 1 or 2 high frequencies, and then decrease back down to a low frequency. And there's an approximately symmetric distribution. The frequencies preceding the high frequency should be roughly a mirror image of those that follow or on the other side of the maximum frequency. The presence of gaps can show that perhaps the data were collected from 2 different populations. However, the converse is not true because data from different populations don't necessarily result in gaps. If we take a look at this table here, what does the gap tell us? And we're looking at the weight of pennies, and we see that there's one cluster here at the top of the table, and then there's nothing in the middle, no observations, and then we see another cluster down here, and we think to ourselves, why might that be? Well, there's a reason for that. There's 2 different populations in that table. Pennies made before 1983 were 95% copper and 5% zinc. They were heavier. And then pennies made after 1983 were 2.5% copper and 97.5% zinc, and they were lighter in weight. Combining 2 or more relative frequency distributions in one table makes the comparison of the data much easier. So for instance, if we wanted to compare McDonald's and Dunkin' Donuts with their drive-through lunch service times, if we put them in a single table, we can see that in McDonald's you tend to get through the line generally faster than if you go to McDonald's. Because of the dramatic differences in the menus, we would expect these times to be very different. McDonald's doesn't serve as many hot items as, Dunkin' Donuts doesn't serve as many hot items as McDonald's. For the table below, find the relative frequencies. So in order to find the relative frequencies, the first thing we need is the total frequency from the table. So we add all the observations in the frequency column and we get 147. Then for each of the classes, we're going to take the frequency, divide by the total, and then multiply by 100. So for the first class, we get 17%, 62.6%, 19%, 0 in the fourth class because there's no observations, and then finally 1.4%. And it's always a good practice to check the percentages and see if they add to 100. When you're finished, you might be able to catch some mistakes in your calculations. Now we want to find the cumulative frequency. So remember, for the cumulative frequency, for the first class, it's simply the observations in that class. For the second class, we're going to take 25 plus 92 and add that together to get the cumulative frequency for class 2. For the third class, we're going to take 117 and add 28. And for the fourth class, it's going to be just 145 again. And then finally, for the last class, we take 145 plus 2 and we get 147. What's wrong with this table? Heights of males, adult males, are known to have a normal distribution as described in this section. A researcher claims to have randomly selected adult males and measured their heights with the relative frequencies shown in this table. Identify two major flaws. The first thing you want to do when you look at a table like this is the first thing you want to do is check to see the percents add up to 100. They don't. They add up to 125%. So that's one mistake. The other one is it told us that they were normally distributed. So we would expect to see a low frequency or relative frequency, higher. The middle group, the middle class, should probably have the highest and then back down again. We don't see that. So therefore, we question whether or not this really is a sample from adult males or if they were calculated correctly. I want to make sure that you remember there are worked example videos for each section, and this link here will take you to the YouTube video that shows you how to actually work some of the homework problems from this section.